Hi everyone, in this video I'm going to talk about the concept of variance and standard deviation. First, we're going to talk about variance. Okay, so in our previous video we talked about the concept of sum of squares to capture the distance of your data between each other, right? Or the distance from the sample mean, to be exact. Okay, the total distances. So sum of squares, okay, it was summation I equals to 1 to n of xi, each sample data point, minus the sample mean, n squared, and then we're going to divide it by n, trying to get the average. Okay, very good. So what's this? This has a name, and this is just your variance. So this whole thing, this formula here, is just your variance. Okay, so this is your variance by definition. Cool. So next, I want to talk about the three types of variance that we're gonna use in this class and their notations. Okay, so for this class. And first one, it's your sample variance. So sample variance is just you have a set of sample data points, and then you find the variance of the sample set. And then this we're denoted with S squared. Okay, S squared to denote your sample variance. And then the formula is summation xi minus x bar squared divided by n. Okay? Now we want to talk about the n that we use here. Since it's your sample data points, and then you're only talking about the sample itself, and then you're talking about the sample variance. You're doing descriptive statistics, so here we use n here. Okay, so that's the first one we have here. Okay, so let me switch it to this side. Okay, second one is our population variance. So this one, we want to be a little bit more careful when we look at this formula here. So first, the notation we use is sigma square, and then this equals to summation I equals to 1 to n. Okay, so in this case, we are saying that we know the population, right? So this one we have to be clear is that we assume that we know the population here. So, and assuming that there are n data points in your population. So we know the whole population. So we're assuming that we know the population. Okay? And then we know each population data point, right? So xi still represents a data point, but we know all the data points in the population, and minus mu. Okay, and then squared. What's mu here? So mu is your population mean. Okay, so sample mean is we get the whole sample, and then we take the average of the sample, where population mean is you get to know, or you already know the whole population, and then you find the mean of the population, so you know everything. So this one here, okay? And then we're divided by n here. Okay, so the question sometimes when I hit this point is, we're doing population, and why we're not doing n minus 1? Okay, we have to note that in this case, because we know all the data points in this population, so we are still doing descriptive statistics because we are describing this population, and we know and we have all the data points of this population. Okay, So in this case, we're still doing descriptive statistics. Okay. Okay, very good. Now I want to introduce you to the third type. The third type is when you don't know the whole population, but you want to estimate the population's variance using sample variance. So this third type here is sample estimation of population variance, right? So we have sample sets, and then we use the sample's variance to estimate for the population variance. Okay, in this case, the notation is sigma hat squared. The hat here is an estimation of the population's variance, right? So it's the hat here. And this equals to summation xi minus x bar square, right? So everything here is from the sample, right? So it's the sample's data points subtracts the sample mean, and then we're going to divide it by n minus 1, right? Because from here on, we are doing inferential statistics because we're using the sample sum of squares to estimate for the population's variance. So here we're doing inferential. Okay, and these three formulas give us you sample variance, population variance, and sample estimation of population variance. Okay, very good. Now we're going to talk about standard deviation. Okay, so standard deviation or SD. Okay, standard deviation. So why do we need standard deviation? So standard deviation is just like it's directly linked to variance. So the problem we had is when we calculate for variance, so when we calculate variance, we square the distances, right? So we square the distance, and then the problem is it's really hard to interpret, right? So if, for example, if we're looking at age, you know, what does it mean to have age squared, right? So the unit is just really hard to interpret. Then how are we gonna solve this problem, right? You just take a square root. To solve the problem, you're gonna just take square root, right? And taking square root will give us standard deviation, right? Give us standard deviation, right? So it just variance, you take the square root, you get standard deviation. Okay, very good. So let me just list out the three standard deviations that we have. Okay, so match the ones we had. So the sample, standard deviation, right? The notation for is S with our square, and that's the square root of your sample variance, and that's just equals to summation xi minus x bar square, and then divided by n. Okay. Then the first one, let's switch this side. Okay, next is our population. Population standard deviation. and you have sigma without the square, because you take the square root, sigma square, and that's equals to, right? Again, here we assume that we know the whole population, right? So we are able to get the sample, not the sample, but population mean here, okay? And then this divided by n. Finally, we're going to have our sample estimation of the population standard deviation. Standard deviation, and then be sigma hat, right? Because it's an estimation equals to square root. And then this equals to summation of your samples, sum of square divided by n minus 1. Okay, so again, we're going to calculate the variance and then we'll take square root to get the standard deviation, and then there's just like a direct link between the two. Okay, very good. Now I want to give you a quick example to talk about or show you how to calculate these values. Okay, so example, we want to calculate for sample standard deviation. Okay, sample deviation, and then the data points we have are 2, 2, 4, 5, 7, and 10, right? We have 6 values here. As you can see, we often, the first thing we want to do is to calculate the sample mean, right? We're going to use it very, very often. So the sample mean is just 2 plus 2 plus 4 plus 5 plus 7 plus 10. They're total 6 numbers. So in our case, n equals to 6. Right, let's denote that first. And then this equals to 30 divided by 6. That's equals to 5. Okay. So we're interested in the sample standard deviation. The first thing we have to do is to find the sample variance, and then we'll take the square root to get the standard deviation. Okay, so we want to find sample variance. Okay, the sample variance here, right? Just plug in the formula. So s squared to denote the sample variance, summation xi minus x bar squared divided by n, right? So the summation means that we have to use each data point to subtract the mean, the sample mean, and then we sum them. So that's equals to 2 minus 5 plus 2 minus 5 squared plus 4 minus 5 squared plus 5 minus 5 squared. And then let me continue from here. 7 minus 5 squared plus 10 minus 5 squared. And then we sum up everything here and divide by n. In our case, n is 6, right? We are doing sample variance, so we're doing descriptive statistics here. That's equals to 48 divided by 6. That's equal to 8. 8 here, it's our sample variance. So this is our sample variance. And then for the sample standard deviation, s, let's just take the square root of s squared. That's equals to square root of 8. This approximately equals to 2.83 here. Okay, and that's how you calculate your sample standard deviation. Very good. Okay, so this concludes this video. and I'll see you in next video. Thank you for watching.